Hi guys, we're starting Unit 5, which is on probability. The next 3 units are all on probability, Units 5, 6, and 7. 5.1a is just Intro to Probability and Simulations. So we'll interpret probability as a long-run relative frequency, and then we'll use simulations to model chance behavior. So first I just wanted to show you guys an example of a simulation. All right, so what's happening in this simulation is we are going to basically see we have 4 babies and they are trying to get to their correct home. It's random which home they go to, so we want to know on average how many babies make it to the correct home. So I'll show you one trial. Here's our stork coming in. Here are 4 babies. Let's see, only one made it. Blue baby made it. Okay, so we can keep doing trials to kind of see what happens. I'll show you another one. And this time, oh, sad day, no babies made it to their correct home. Okay, so you can see in these graphs down here, we have number of matches on the x-axis versus how often that happens. So far, we've only had 2 trials, right? One trial, no babies made it to the correct home. One trial, 1 baby made it to the correct home. So average matches, here we had 1, then we had 0.5, right? Because 1 and 0. These 2 trials average out to be 0.5. So this is kind of our running average here. So we obviously need to do a lot of trials to get a good idea of the average number of babies that make it to the correct home. So let's do 100 trials. I'm not going to animate it 100 times. You can see the counts changing here though. So 43 times we saw 0 matches, 26 times we saw 1 match, 30 times we saw 2 matches, 3 times we saw 4 matches. That's putting our average number of babies making it to the correct home at 0.961. So you can see the distribution here. And then look what's happening at our running average. You guys can see that at first, it was very sporadic, right? The average changed a lot. This is when we had few number of trials, but as we did more trials, you guys can see that it's starting, well, the average is starting to average out. So let's do 100 more trials. You guys can see that this is approaching a single value. The more and more trials we do, we can see that the average number of babies that make it to the correct home is 1. So this brings us to our idea of kind of what probability is. Chance behavior is unpredictable in the short run, but it has a regular and predictable pattern in the long run. So the law of large numbers says that if we observe more and more repetitions of any chance process, the proportion of times that a specific outcome occurs will approach a single value. That's what we saw with the babies. The more and more repetitions of that process that we saw that the average was approaching 1. Okay, that value that it approaches, that's what we call the probability. So if we think in terms of how many babies we had an average of 1. 1 out of 4 would give us 25% chance. Same idea here. Here we have coin tosses. Everybody knows that probability of flipping heads is 50-50. But of course, if you did it 5, or 10 times, you may not see that exactly 50% of the time, right? If you flip a coin 10 times, you might see heads every single time. That's because probability is unpredictable in the short run. But you guys can see, so this one we go up to about 20 trials. You guys can see that it starts to approach 0.5. But as we do even more trials, this goes up to 500, you guys can see that it starts to average out to be at 50%. So again, this is just the idea that the more repetitions you observe, it's going to approach that single value that we call the probability. So probability of any outcome of a chance process is a number between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of repetitions. 0 means it's impossible, it will never happen. If something has a probability of 1, that means it is guaranteed to happen. It will always occur. We can express probability as a decimal, we can express it as a fraction, we can express it as a percent. We don't care, any of them will do. And to interpret probability, we interpret it as the long-run relative frequency over many, many trials. So here's a little example where we interpret a probability. So the probability of getting a sum of 7 when rolling 2 dice is 1 out of 6. So let's interpret that value, 1 out of 6. If we roll 2 dice many, many times, the sum of 7 would happen about a sixth of the time. So again, we want to make sure we incorporate this long-term idea, right? We would have to roll 2 dice many, many, many times. And over the course of those many times, the sum of 7 would happen about a sixth of the time. So you have a couple homework problems where you're going to use this sentence to interpret probabilities. A couple myths about randomness. Same idea here, short run regularity. Probability is predictable in the long run, not in the short run. So don't apply the law of large numbers to a small number of trials, okay? If you flip a coin 10 times, anything could happen. But if you flip a coin 1,000,000 times, you should see 50% heads, 50% tails. The myth of the law of averages. Again, we know random behavior evens out in the long run, but future outcomes are not affected by past behavior. So that's another common misconception that people think. What happened in the past does not affect what's going to happen in the future. So if you flip heads 10 times in a row, that's not going to affect the 11th flip, okay? You still have a 50-50 chance of flipping heads. So just make sure you guys understand that past outcomes do not change the probability of future outcomes. So let's start talking about simulations. I already showed you an example of a simulation with the babies, but the imitation of chance behavior based on a model that accurately reflects the situation is called a simulation. So this just helps us estimate probabilities when they're difficult to calculate theoretically. And sometimes probability can get complicated very quickly, so sometimes it's easier to do a simulation and kind of see what happens. So we'll do some problems in 5.1b where we perform a simulation, but these are the steps we're going to use. So first off, the state step, you guys are going to want to restate the question of interest. In the plan step, you're going to describe how to use some sort of chance device to imitate one repetition of the process. And remember, our chance devices are pieces of paper and a hat, the random digit table, your calculator, random integer. And then you're going to say what you'll record at the end of each repetition. In the do step, you're actually going to perform repetitions of, sorry. I'm sorry if I just hurt your ears with those dogs, but I'm not re-recording this whole thing. So in the do step, we perform repetitions of whatever simulation we're doing. And then in the conclude step, we use the results to answer the question of interest. And we can use physical devices like pieces of paper and a hat, the random number table, or technology to perform our simulations. So go ahead, go to the 5.1b video, and we'll do a few examples of simulations.